Okay, this is Chapter 3's final on powers and exponents. This is last year's 2023, I suppose. Question 1 says 5 to the exponent 4 true or false is equal to 5 plus 5 plus 5 plus 5. The answer for this, of course, is false. And if you had to say why, it's because powers do not express repeated addition, they express repeated multiplication. That's the reason why. Question 2, it says negative 2 in brackets with a 2 inside the brackets is the same thing as negative 2 there. Well, the first thing you have to realize is that negative 2 with the 2 inside or outside are completely different things. The reason why this is inside, these are not the same thing. This is negative 2 squared. This is the opposite of 2 squared. The opposite of 2 squared. So therefore, this is going to be negative 4. And, and this is also the opposite of 2 squared, which is negative 4. So therefore, it is true they are both equal to negative 4. Question 3 gives you the question negative 2 in brackets, which is the base to the exponent of 3 multiplied by negative 2 in brackets to the exponent of 5, divided by negative 2 in brackets to the exponent of 4, is the same thing as negative 2 in brackets to the exponent of 13. True or false? Well, the first thing you want to do is you want to solve your multiplication. And since these are the same base, you can keep your base and add your exponents, giving you negative 2 to the 8 divided by negative 2 to the 4. And when we think about division of the same base, you can keep your base and subtract your exponents. And since negative 2 to the 4 does not equal negative 2 to the 13, then we say, was it 11? 11, sorry. Then we can say false, they are not the same thing. And that's why. Question 4, true and false, says 2 plus 5 in brackets to the exponent of 3 is equal to 2 cubed plus 5 cubed. You should have went around the corner. Why didn't you go all the way around the corner and escape? Oh. Oh, sorry, I'm recording. I forgot. Sorry, we were recording a video here. Anyway, law number 4, it kind of looks like you can distribute them cubed, but you can't. Law number 4 is if it's multiplication, and law number 5 is division. But if it's addition or subtraction, there is no law for that, so this is not equal. And we can check it out with BEDMAS. If we tried it with BEDMAS, and I simplified each power, 7 cubed is 243, and 8 plus 125 is 133. Since they don't equal each other, we could say false. That is not true. Question 5, it says negative 2 multiplied by negative 3 to the exponent of 3 is greater than 0. Is this true or false? So really it's a BEDMAS question. Can you solve this BEDMAS? Of course, in BEDMAS we have B, we have E, we have D, we have M, we have A, we have S. We have 4 steps. First thing we're going to do is our brackets. There's nothing inside there, just negative 3, so there's nothing there. Next thing we do is our exponents. There is. Negative 3 cubed is negative 3 times negative 3 times negative 3, which is negative 27. And negative 27 times negative 2 is positive 54. And since the positive 54 is greater than 0, we say that this is true. 54 is greater than 0. And finally, in the true-false question 6, square brackets, negative 2 cubed, end of square brackets cubed. This is actually an example of law number 3, a power to a power is greater than 0. Is this true or false? Well, we know that when we have a power to a power, the law says we keep our base and multiply our exponents. And if we don't have to know what negative 2 to the 9 is. If we do know, that's great. If we don't know, that's okay as well. We know it's a negative base to an odd exponent, so it's going to be a negative number. I don't even care what the answer is. And is it possible that a negative number is greater than 0? No. Therefore, the answer is false. It is impossible for a negative number, regardless of what it is, to be greater than 0. Just for the record, if we did take a calculator and say, what is negative 2 xy 9, it'll tell us it's negative 512. So negative 512 is definitely not greater than 0. Okay, question 7. So it gives us this question which says the power of the repeated multiplication of the value. The first one is negative 10 in brackets to the exponent of 6. In repeated multiplication, that's negative 10 times negative 10 times negative 10. I'm lazy. Times negative 10 times negative 10 times negative 10. And we know from our experience a negative base to an even exponent will be a positive value. And we also know that when we have a base 10 to an exponent, the easiest way to write it in standard notation is to put a 1 down, and whatever your exponent is, that's how many zeros you put down. So in this case, 1 million is your standard value, or positive 1 million. In the second question, it gives us this as our repeated multiplication. And by looking at that, you have to say, I know what that says. That says the opposite of 5 squared, or the opposite of 5 times 5. The opposite of 5 times 5. The opposite of 5 times 5 is the opposite of 5 squared. It is not this. It is not this. That is not what it says. It's not negative 5 times negative 5, because that would look like this. Right? That's negative 5 times negative 5. This says the opposite of 5 squared, or multiplying 5 times 5 by negative 1 to get the opposite of 5 squared. And its value is negative 25, not positive 25. And our last question just gives us 256 over here with a weird base and a 4 up here. We have to figure out what is the base if the answer is 256. I think the answer is it 4? It is. It's 4 times 4 times 4 times 4. That's 16. That's 16. And using associative property, I know 16 times 16 is the same thing as 4 times 4 times 4 times 4. Therefore, your standard form is, or your repeated multiplication is that. Okay, question 8. Question 8 asks us to define the terms. It says, what is the 2 called? It's called the coefficient. And when we learned coefficients, you learned them back in algebra, like 2x. It takes an unknown value, in this case x, and it multiplies it by 2. In this case, we're taking a power, which technically is unknown because we don't really know its value yet because we haven't simplified it, and we're multiplying it by 2. So it's kind of the same thing. The negative 3 in terms of a power is called the base, and the 4 is called the exponent. And I'm too lazy to write the whole thing out, so I'll just put exponent. Question 9. Question 9 gives us this and says, write as the product of 2 powers. Okay? So since this can be expressed as a power, this would be 2 to the exponent of 4, multiplied by a second power, which is 2 to the power of 2. That's expressing it as 2 powers. Then, write as a single power. Well, we know we have 2 bases that are the same, and if we're multiplying them, we can keep the base and add our exponents, giving us a single power of 2 to the exponent of 6. And simplifying it means, what is its value? 2, 4, 8, 16, 32, 64 is its value. So for question number 9, that's expressing it as 2 powers. That's as a single power, and that's its value. That's just showing how you got the single power. Question number, Question number 10 says, write as the quotient of 2 powers, which means the division of 2 powers, a single power, and then write its value. So the top number here is negative 3 in brackets. That's the base to the power of 5. This line means divided by this power here, which is just going to be negative 3 to the exponent of 1. Law 2 says when you divide 2 powers that have the same base, keep the base. Subtract your exponents. Your single power simplification of this question will be negative 3 to the power of 4. And since I know that this is 9 times 9, same thing, positive 9 times positive 9, your standard form will be 81. Question 11, Madison, says 10 times 10 in brackets, and then this is multiplied by itself 3 times. So what you have when you have this here is you say, well, this is a power. This is 10 squared. And it is 10 squared 3 times, or it's being multiplied by itself 3 times. So then, therefore, we can put a 3 out there to say that is 10 squared cubed. That is the product, the power to an exponent. As a single power using law 3, when we have a power to exponent, we keep the base and multiply our exponents. As a single power, it's 10 to the 6. And just like the true-false, when you have a base 10 to any exponent, put down a 1, and your exponent will tell you how many zeros to put. The answer, again, is 1 million. Question number 12 says arrange these powers. Arrange these powers, there's 5 of them, in descending order value. So what we're going to do, I'll grab my red marker here. I'm just going to simplify all of these. I know this says the opposite of 5 squared. So standard form will be negative 25. I know this says negative 2 cubed, and negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. The opposite of 1 to the 22, well, 1 to the 22, if I just ignored this sign here for a second, that's going to be 1, because 1 multiplied by itself 22 times is still 1. And the opposite of 1 is negative 1, right? Just remember, some of you might have thought it was positive 1, but that is equal to positive 1, right? Because it's a negative base to an even exponent. The difference being there's no brackets around the base, which means the base is really just 1, and the opposite of 1 to the 22 is negative 1. Here we have a base defined with brackets. Negative 4 squared is positive 16. And finally, any base, including this one here, to the exponent of 0 is 1. So therefore, your standard form is 1. Once we have that, it says descending order of value, meaning the greatest value first. I'll use blue for this because it's pretty. The greatest value is this. My apologies, I wrote that wrong. I'm going to go back in time. This should have been to the exponent of 1. I wrote it down wrong, which is just going to be negative 4, which I better erase this and put negative 4, and then I'll start my thing again. Thank you for correcting. The greatest value is actually this one. That's our largest value. Our next largest value is this. Our next largest value is this. Madison, thank you very much. Next largest value is this. And finally, our smallest value is this. Question 13. For questions 13 to 18, it says use BEDMAS to solve. So the first question is this. If we use BEDMAS, we're going to solve according to order of operations. I have an exponent, I have an addition sign, I have an exponent, do my exponents first. The opposite of 2 to the 2 squared is negative 4, and negative 2 cubed is negative 8, and negative 4 plus negative 8. Standard form, simplified, is negative 12. Question 14 says 4 cubed minus 2 plus 4 in brackets squared plus 1 to the 10th. So here, for BEDMAS, we have an exponent, we have a subtraction, we have brackets, because there's something inside there. We have an exponent, we have an addition, and we have an exponent. We have a lot of stuff going on here. The first thing we do in BEDMAS is our brackets, so technically, my next line will look like 4 cubed minus 6 squared. You can keep your 6 in brackets, plus 1 to the 10th. We now have a lot of exponents. We're going to simplify it. That's 64 minus 36 plus 1. A lot of mistakes are made right here. Even the most ardent person might put 10 down there accidentally. But 1 multiplied by itself 10 times is still that. 64 take away 36 is 28. 28 plus 1 is 29. Question 15 says 5 minus 8 cubed minus negative 2 to the 4th. Here again we have brackets, which are something to do, exponents, subtraction, and exponents. Those are all of our operational steps. 5 take away 8. A lot of people, I don't know how many people, but a lot of people think it's 3. It's negative 3. We then have exponents and subtraction left. Negative 3 cubed is negative 27. And negative 2 to the 4th is 2, 4, 8, 16, a positive 16. Notice how, this is important because I've mentioned it now 10 times. That subtraction symbol is still a subtraction symbol. It has to go down there just like that. And since this power is positive 16, I have to use brackets to separate the positiveness of the 16 from the subtraction symbol. At this point, I'm subtracting. This is a grade 7 question. Keep, flip, change. Negative 27 plus negative 16 is negative 43 in standard form. Question 16, 2 cubed times 2 cubed plus 4 to the 0 times 10 squared divided by 10 to the 1. Looks complicated, not that bad. Looks complicated, not that bad. We know that we don't have any brackets, so we just have exponents. So I'm going to simplify every power. 2 cubed is 8. 2 cubed is 8. 4 to the 0, any base to the 0 is 1. 10 squared is 100. Remember, operation symbol in here is what? Operational symbol right here. Multiplication. So I have to put the multiplication down. Divided by 10 to the 1, anything to the power of 1 is itself. This is looking easier. When you have multiple operations in the numerator, you simplify that. It's treated like brackets. So 8 times 8 is 64, plus 1 times 10, which is 10, divided by 10. 64 plus 10 is 74. Now that I've simplified my top part, 74 divided by 10. It's a piece of cake because you just have to move the decimal one spot. You get 7.4. Is that the right answer, by the way? Did I make a mistake, or is that good? You got that answer? Okay. Question number 17. Threw a lot of people for loops here. Fraction squared plus fraction cubed. The easiest way to do it is just to simplify these using, I think, law 5. Is that what it is? Since it's a fraction, you can apply the exponent to both parts, or 2 squared over 3 squared, plus 1 cubed over 2 cubed. When I look at that, I'm like, okay, I can simplify this. 2 squared is 4. So really, 2/3 times 2/3 is 4/9. If I think of it as 2/3 squared as 2/3 times 2/3, it makes sense that it's 4/9. If I think about 1/2 cubed, it's 1/2 times 1/2 times 1/2. It makes sense that it's 1/8. So now that I've simplified my exponents, I end up with this really easy grade 7 question on adding fractions. 4/9 plus 1/8. Something less than half plus something less than half. I know my answer is going to be less than 1. Common denominator is 72. Equivalent fraction, 32. 9. Keep your base, add your exponents, or add your numerator, sorry. Your final answer is 41 over 72. That's a tricky question. But as you can see, it's not that hard because you just had to know how to apply your exponent laws to fractions. And once you did, you got this. And once you simplified those, you got this. And once you got to that step there, it's really just a grade 7 question from that point forward. Question 18 says 10, this is question 18, 10 squared times 10 to the 5th divided by 10 to the 6th minus square brackets 2 times -3 squared, end of square brackets. Again, looks complicated, not that bad. If I was you, how would I simplify that? Would I change them all to standard form right now, or would I use a law? I'd probably use a law, wouldn't I? That's prime for using which laws? What laws is it? Law 1 and Law 2. The multiplication of powers that have the same base, you can keep the base and add the exponents. The division of two powers that have the same base is keep the base, subtract the exponents. So when you do that whole thing, not simplifying the exponents down to standard form, but just using your laws, you just get the number 10, which makes this question significantly easier because it's just 10. In here, 2 times -3 squared will be 2 times 9, or 18. And your last step, 10 take away 18. Excellent. Your final answer is -8. I hope that's not a guess in grade 9. If you don't know what 10 take away 18, don't say it. You weren't paying attention. That's shocking. That's shocking. Shock! And question 19, we didn't have to do. The answer was -8. Oh, you want me to do 19? I'll do 19 anyway. So, it's okay. I'm just going to show you. The formula that I haven't taught you yet is this. Listen, this is the formula for exponential growth. I might as well do this now anyway, because we're going to do it starting number. Just pay attention. It's not that hard. It's really easy, actually. R is your rate of change. And T is your number of time units, number of time intervals. We'll call it intervals. This is your formula for exponential growth. So if you read the question, it says 20 bacterium are in a Petri dish. That is going to be our starting number. So I'm going to put 20 multiplied by the rate of change. That's our starting number. So starting number of bacterium is 20. They will quadruple every 2 minutes. So quadrupling is going to be the number 4 for the rate of change. Quadrupling is represented with 4. Every 2 minutes. How many will there be after 10 minutes? So how many 2-minute intervals are there in 10 minutes, Carter? How many 2 seconds are there in 10 seconds? That's right. So for the number of time intervals, there are 5 2-second intervals in 10 seconds. So if there's 20 starting bacterium and they quadruple every 2 minutes for 10 minutes, that's going to be 5 intervals. If I simplify this, that's how many bacterium will be in the dish after 10 minutes. So first thing I'm going to do is go, what's 4 to the exponent of 5? 1,024. And 1,024 times 20 is 20480. So after 10 minutes, there will be 20,480 bacteria.